Our planet's ice is huge, ancient, and in constant motion. From Antarctica's ice sheets that shape the world's climate to the fast-flowing glaciers in Alaska, Greenland, and the Himalayas, these frozen giants hold most of the Earth's fresh water. Here are 20 of the biggest ice shelves and glaciers on the Earth. Number 20. The Columbia Glacier in Alaska. Columbia Glacier is located in Prince William Sound on Alaska's southern coast. It's one of the most dynamic and closely studied tidewater glaciers in the world. It goes for around 64 kilometers or 40 miles from its origins in the Chugach Mountains to the sea. This immense area of ice once extended all the way to Heather Island near Valdez, and today it's a dramatic example of how rapidly glaciers can retreat. In the early 1980s, the glacier began an accelerated retreat after being stable for centuries. Satellite imagery and aerial photography show that since then, it's lost more than half its total length, retreating over 12 miles inland. The ice front now ends in deep water, where it calves massive icebergs into Columbia Bay, and some of those are as large as office buildings. These floating chunks of ice are a constant hazard for marine traffic, and they're often visible to visitors from sightseeing boats and aircraft. But despite the retreat, Columbia Glacier remains enormous. The ice thickness still exceeds 900 meters or 3,000 feet in places, and it drains an area of more than 1,000 square kilometers or about 390 square miles. Its ice flow continues to reshape the surrounding fjord, deepening it as the ice melts and sediments shift. Researchers have monitored Columbia for decades because its behavior closely mirrors trends seen in Greenland and Antarctica, and its retreat is primarily caused by warm ocean water eroding the glacier's terminus from below. That's a process called submarine melting. This glacier's transformation has become a textbook case for understanding tidewater glacier instability. Even so, it remains one of the coolest natural features in Alaska. It's framed by rugged peaks and surrounded by floating ice, and visitors often describe the thunderous sound of the calving ice echoing across the bay. Though ancient and seemingly frozen in time, they are alive with motion and change. Number 19. The Jakobshavn Glacier in Greenland. The Jakobshavn Glacier is Greenland's fastest-moving and most productive glacier. It's located near the town of Aleutiat on the island's west coast. It flows westward into the Aleutiat ice fjord. The glacier drains about 7% of Greenland's entire ice sheet. It goes on for more than 40 miles inland, and it reaches widths of up to 5 kilometers or about 3 miles. Its ice front stands hundreds of meters tall above the fjord's surface, and the ice below the waterline extends even deeper. At its fastest, the glacier has been recorded moving over 40 meters or 130 feet per day, which makes it one of the fastest moving glaciers. For centuries, it's been calving icebergs into the fjord that then drift into Disco Bay and out into the North Atlantic. It's believed that the iceberg that sank the Titanic in 1912 originated from this glacier. Each year, it releases enough ice into the ocean to supply fresh water to every human on Earth for several months. Satellite and radar measurements show that the glacier has thinned out by more than 1,500 meters, that's about a mile, near its grounding line since the 1980s. The retreat has accelerated the flow of inland ice towards the sea, which contributes measurably to global sea level rise. But still, it's not collapsing uncontrollably. In recent years, cooler ocean cycles have slowed its retreat, and part of the glacier have thickened slightly. Scientists view these fluctuations as a reminder that glacial systems respond not just to global temperature, but to complex oceanographic and atmospheric feedback. As seen from above, though, it is one of the most awe-inspiring sights. A vast, slow-moving conveyor belt of ice, cracking and calving as it pushes its frozen cargo towards the sea. Number 18. The Perito Moreno Glacier in Patagonia. Located in Los Glaciares National Park in southern Argentina, the Perito Moreno Glacier is one of the few major glaciers on Earth that remain in a state of equilibrium, neither rapidly retreating nor advancing. It stretches about 19 miles from the southern Patagonian ice field, and it stands about 70 meters or 230 feet above the surface of Lake Argentino, with an ice depth reaching more than 700 meters or 2,300 feet below the waterline. Now, unlike most glaciers that are retreating under modern warming, Perito Moreno's stability makes it an anomaly of sorts. The glacier continuously advances across the southern arm of Lake Argentino, occasionally damming the lake's waters and creating a natural ice barrier. Over time, this trapped water builds pressure until it breaks through the ice wall in a spectacular rupture event. These events, which can happen every few years, are among the most dramatic spectacles in South America. Massive sections of ice collapse and crash into the lake below, sending waves reverberating through the fjord. The glacier here provides valuable insight into how local conditions can stabilize even large masses in a warming climate. Researchers have used radar, satellite imaging, and field surveys to track Perito Moreno's flow rate, that's around 2 meters per day at its center, and study how the glacier interacts with the lake below. The interface between the fresh meltwater and the denser subglacial lake water does play a role in controlling these calving rates and ice movement. It's not isolated in deep polar terrain, it's easily reachable, it's alive with motion, and it's brilliantly colored by sunlight and air bubbles trapped within the ancient ice. For scientists and visitors, it's a rare and uplifting example of balance within the world's changing cryosphere. It's a glacier that endures, where so many others are shrinking. Number 17. The Vatnajökull Ice Cap. Vatnajökull, located on southeastern Iceland, it's the largest ice cap in Europe by volume and area. Covers about 7,900 square kilometers or just over 3,000 square miles and spans about 8% of Iceland's total land mass. The ice averages about 400 to 600 meters, that's 1,300 to 2,000 feet thick, with the thickest parts exceeding over 900 meters or 3,000 feet. Beneath it are active volcanoes, making it one of the most geologically complex ice formations on Earth. Meltwater from its glaciers feed major rivers, which have carved out these glacial plains and canyons. And because of the underlying geothermal activity, the ice cap does experience occasional subglacial volcanic eruptions. When those happen, the trapped meltwater beneath the ice can suddenly burst forth in a catastrophic flood, capable of sweeping away bridges and reshaping entire landscapes. Vatnajökull's outlet glaciers are among Iceland's most photographed natural wonders. For instance, one of them feeds the famous Jökulsárlón glacial lagoon, where massive icebergs break off and drift towards the Atlantic. These vivid blue icebergs have become an iconic symbol of Iceland's scenery, and they appear in numerous films and documentaries. Although Vatnajökull is receding overall, its retreat has been relatively moderate compared to glaciers at lower latitudes. Iceland's high latitude and abundant snowfall do allow portions of the ice cap to persist even as temperatures rise. In 2019, the national park here encompassing the ice cap and the surrounding area was designated a UNESCO World Heritage Site. But standing atop Vatnajökull, you can literally feel the Earth's opposing forces at work, frozen rivers of ice resting on one of the planet's most active volcanic zones. Number 16. The Siachen Glacier. The Siachen Glacier is high in the eastern Karakoram mountain range between the borders of India and Pakistan. At roughly 47 miles long, it is the longest glacier in the world outside of the polar regions, and it covers an area of about 270 square miles. It originates near the Indira Col and flows southeast through terrain surrounded by mountains that rise above 23,000 feet. Since 1984, India and Pakistan have maintained permanent military outposts here, making it the highest battlefield in the world. These conditions, with the temperatures dropping below -40 degrees Celsius, the air is thin enough to challenge even acclimatized soldiers. It poses far greater dangers than the combat itself. Avalanches, altitude sickness, and frostbite are also constant threats. But despite the political significance here, Siachen is also an invaluable natural resource. It feeds the Nubra River, which eventually joins the Indus River, supporting downstream communities and agriculture. Its snow and ice stores are vital to the hydrology of the Indian subcontinent. Research expeditions, though rare due to security, has shown that the glacier's been thinning and retreating over the past few decades. Satellite imagery from the Indian Space Research Organization and NASA shows a steady loss in ice mass, especially at lower altitudes. Still, though, the upper reaches of the glacier remain relatively stable thanks to the heavy annual snowfall and the extreme cold of the high Karakoram. But beyond politics and science, the glacier here holds a symbolic importance as a place where two nations continue to guard frozen territory. The scale of it, the location of it's all earned a reputation as an example of human endurance and a reminder of how the world's great glaciers can become frontiers not only of nature, but of national identity. Number 15. The Lambert Glacier. The Lambert Glacier is located in East Antarctica. It is the largest glacier in the world. It stretches for about 250 miles, and it's more than 25 miles wide in some area, draining roughly 8% of the entire East Antarctic ice sheet. This enormous river of ice flows northwards from the inner plateau of Antarctica, eventually feeding into the Amory ice shelf along the coast. Discovered and named by the Australian National Antarctic Research Expeditions in the 1950s, Lambert Glacier has been studied extensively due to its size and its influence on the global ice system. The glacier's surface speed can exceed about 3/4 of a mile per year, which carries colossal volumes of ice towards the ocean. Beneath the glacier is a deep trough more than 8,200 feet below sea level, making it one of the lowest points on the Antarctic continent. Scientists estimate that if the glacier's flow were to accelerate significantly, it could have a measurable effect on global sea levels. However, unlike many glaciers in West Antarctica, Lambert has remained relatively stable in the recent decades. The cold ocean currents surrounding it have so far insulated it from the warm water intrusions that have triggered rapid ice loss elsewhere, and satellite data from missions like Cryosat and IceSat-2 show that the glacier experiences small annual fluctuations but no large-scale retreat. Researchers are really interested in how its grounding line, that's the boundary where the glacier stops resting on land and begins to float, corresponds to change in ocean temperature and salinity beneath the Amory ice shelf. It represents both stability and potential vulnerability. It's a frozen giant that holds huge amounts of the world's fresh water, and it's all locked away in a continent where even small shifts in ocean heat can alter the fate of all the world. Number 14. The Uppsala Glacier in Patagonia. The Uppsala Glacier is in the Los Glaciares National Park in Argentina, which is west of Lake Argentino. It's one of the largest glaciers in South America, and it goes on for more than 31 miles in length, and it covers an area of about 330 square miles. It originates from the huge southern Patagonian ice field. That's one of the biggest ice masses outside of Antarctica and Greenland, and it flows eastward before terminating in the waters of Lake Argentino. Now, Uppsala's immense front is known for its vivid blue ice. It's punctuated by deep crevasses and towering pinnacles that calve into the lake. Since the early 1990s, it's receded more than 6 miles, leaving behind new fjords and lagoons where solid ice once stood, and satellite and field measurements confirm that Uppsala has been losing both length and thickness due to rising temperatures and the warming of the lake water at its terminus. Scientists from Argentina and Chile, along with international research teams, use this glacier to monitor how warm air and water interact with ice fronts. The behavior of the glacier mirrors the other retreating systems in Patagonia, like the O'Higgins and Viedma glaciers, which also are experiencing similar losses. Oh, and Uppsala was named in honor of Uppsala University in Sweden, whose scientists were among the first to study the region's glaciology, and today it's accessible by boat tours, giving visitors chances to witness the dramatic landscape firsthand. Even in decline, Uppsala is amazing looking. The fractured ice walls, luminous under the southern sun. It shows the planet's shifting balance between cold and warmth. Number 13. The Athabasca Glacier in Alberta. Located in Jasper National Park in Alberta, the Athabasca Glacier is one of the most accessible glaciers in the world. It's about 3.5 miles long and covers about 2.3 square miles. It flows down from the ice field's huge accumulation zone along the Continental Divide, which feeds both the Pacific and the Atlantic drainage basins. Athabasca is one of the 6 principal outlet glaciers of the Columbia ice field, which spans about 125 square miles. Because it's easily accessible from the Icefield's Parkway, which is a major highway that connects Jasper and Banff, Athabasca has become a key site for public education about glaciers. However, its visibility makes its retreat impossible to ignore. Historical photographs and surveys show that since the late 19th century, the Athabasca Glacier has retreated more than 1.5 kilometers, that's nearly a mile, and lost over half its total volume. Scientists from Parks Canada and research institutions are monitoring the glacier's mass balance annually. They found that the main causes of its retreat are warming summer temperatures, reduced snowfall, and changes in precipitation patterns. But visitors can safely approach the glacier through a guided ice explorer tour, vehicles, or on foot with experienced guides. It remains a powerful educational tool. Standing at its terminus, where the icy meltwater rushes over newly exposed rock, it's easy to understand how glaciers shape landscapes and history. Number 12. The Aletsch Glacier, Switzerland. The Aletsch Glacier, located in the Bernese Alps of southern Switzerland, is the largest glacier in the entire Alps and one of Europe's most amazing natural landmarks. It stretches for about 14 miles in length, covers an area of about 31 square miles, and it's fed by the convergence of several smaller glaciers, the Jungfrau, the Munk, and the Eiger tributaries. It forms a massive river of ice that winds through the mountains towards the Rhone Valley. The glacier's upper section, the Grosser Aletschfjord, originates high in the Jungfrau region at elevations above 12,000 feet. And from there, the ice moves downslope at a rate of several meters per year. The immense pressure and slow movement compress the snow into deep blue, crystalline ice that glistens beneath the Swiss sun. This glacier was one of the first to be systematically studied in the 19th century, which helped to establish modern glaciology. Today, it's one of the best monitored ice bodies in Europe, with decades of data on its movement, temperature, and volume changes. Its retreat has exposed entire valleys that were once hidden under the ice. Satellite data and aerial surveys reveal new lakes forming in its wake, ephemeral meltwater pools that mark the glacier's former boundaries. And in 2001, the surrounding area was designated as part of a UNESCO World Heritage Site in recognition of its geology and its role as a climate indicator. Standing above it, you can see more than just ice. You can witness a timeline that is written into the land itself, showing how Europe's frozen heart continues to shift under the pressure of a warming world. Number 11. The Furtwängler Glacier, Tanzania. The Furtwängler Glacier, that's a really cool name, sits near the summit of Mount Kilimanjaro in Tanzania, at an elevation of nearly 19,000 feet. It is one of the last remnants of what was once a vast ice cap that covered the mountain's upper slopes. Named after the German explorer, of course he's German, Walter Furtwängler, who was among the first to climb Kilimanjaro in 1912, this glacier is an iconic symbol of tropical glacial retreat. At its peak, around 11,000 years ago, the ice summit on Kilimanjaro extended over 7.5 square miles. By the early 20th century, it had shrunk dramatically, and by 2020, less than 0.4 square miles of permanent ice remained. Unlike most glaciers formed in polar climates, this one's ice cap developed from atmospheric moisture carried up from the Indian Ocean. As regional climates have warmed and humidity patterns have shifted, the ice has thinned rapidly here. The glacier now loses ice through sublimation, where it turns directly from a solid into a vapor rather than melting into water, which is an unusual process that shows the delicate balance of high-altitude tropical glaciers. Scientists from the University of Innsbruck and Ohio State University have studied ice cores from the glacier to reconstruct East Africa's climatic history over millennia, and this data shows major shifts in precipitation and temperature, invaluable information not just for Africa, but understanding our global climate trend. Estimates suggest that if current conditions persist, the Furtwängler Glacier, and with it Kilimanjaro's famous ice cap, could disappear entirely within the next decade or two. Number 10. The Hubbard Glacier. The Hubbard Glacier, straddling the border between Alaska and Canada's Yukon Territory, is the largest tidewater glacier in North America. It measures about 76 miles in length and covers 1,300 square miles. Unlike many glaciers around the world that are retreating, Hubbard has been advancing for more than a century, a rare case of a glacier growing rather than shrinking in modern times. Originating from Mount Walsh in Canada's St. Elias Mountains, this glacier flows southwest towards Disenchantment Bay and Russell Fjord, ending in a 300-foot ice wall that regularly calves massive icebergs. The glacier's face is roughly 6 miles wide, which creates an extraordinary spectacle that draws in scientists and visitors from all over. The fjord in which it flows is deep and narrow, which stabilizes the glacier's front and reduces the speed at which it calves icebergs. As a result, Hubbard's forward motion is outpacing its melting, allowing it to expand slowly towards the sea. In both 1986 and 2002, the glacier temporarily blocked the mouth of Russell Fjord, creating a massive ice dam that trapped seawater and caused the fjord's water level to rise by nearly 80 feet. When the ice dams eventually gave way, the sudden release of water generated a powerful outburst flood, and scientists continue to monitor the glacier closely for signs of another potential blockage. For now, though, Hubbard is a reminder that not all glaciers respond identically to climate. It is an advancing giant, an exception that proves the complexity of the Earth's frozen systems. Number 9. The Lambert-Amory System in East Antarctica. The Lambert-Amory system in East Antarctica is the largest glacial drainage network on the planet. It consists of the Lambert Glacier, we talked about that one, and the adjoining Amory ice shelf, which forms its floating extension into the Southern Ocean. Combined, they stretch over 310 miles and drain roughly 1 million square kilometers or 390,000 square miles of the East Antarctic ice sheet. At its thickest point, the glacier is more than 8,200 feet deep. That's deeper than many mountains. When it reaches the coast, it merges with the Amory ice shelf. That's a floating platform of ice nearly 23,000 square miles in size. Together, they're like a massive conveyor belt transferring inland ice into the ocean. Satellite altimetry and radar data show minor seasonal fluctuations, but no large-scale collapse or acceleration, and that suggests that cold water currents in the region are still protecting the ice shelf from the warmer circumpolar deep water that's destabilized other parts of the continent. The grounding line, where the glacier transitions from land-based to floating, rests on bedrock way below sea level. If warm ocean water were to ever penetrate deep into this cavity, it could begin to melt the ice from below, leading to a chain reaction of retreat. Scientists, of course, are monitoring this area closely, using ice-penetrating radar and satellite interferometry to measure subtle movements of the ice front. Viewed from above, this whole system is a colossal frozen river system. It's larger than many countries combined. It's an anchor of Antarctic stability and kind of like a sleeping giant. It stores enough ice to raise global sea levels by several meters if it were to ever lose its balance. Number 8. The San Rafael Glacier, northern Patagonia. In Chile's northern Patagonian ice field, the San Rafael Glacier flows into the head of Laguna San Rafael, a fjord connected to the Pacific Ocean through the Moraleda Channel. It stretches for about 28 miles and a length of over 290 miles. It is one of the largest glaciers in Chile and one of the most active calving glaciers in the southern hemisphere. The glacier descends from the Andes, moving steadily towards the sea where its 230-foot ice wall meets the waters of the lagoon. San Rafael is famous for its icebergs, which constantly are breaking from the face with explosive cracks that echo across the fjord. The sight is awesome and sobering. This is a glacier that's been retreating rapidly for decades. Since the late 19th century, it's receded more than 6 miles, and early explorers in the 1870s described the glacier reaching the outer edge of the lagoon, but modern satellite data show its front has pulled back significantly inland. In addition, rising air temperatures and increased rainfall, rather than snowfall, are accelerating surface melting in the accumulation zone. Chilean and international scientists are conducting ongoing studies using satellite radar, autonomous drones, and hydrographic sensors to monitor water temperatures and ice flow. These all provide valuable data to the behavior of tidewater glaciers in Greenland and Alaska too. Tour boats bring small groups of people to witness the spectacle in this UNESCO Biosphere Reserve, an immense creaking wall of blue ice that constantly is reshaping the lagoon below. This glacier is a remnant of the last ice age. It reveals how quickly the world's temperate glaciers can change in the face of any warming. Number 7. Gangotri Glacier, India. The Gangotri Glacier in the high Garhwal Himalayas of northern India. It's one of the most important glaciers in Asia. It spans about 19 miles in length and 1.5 to 2.5 miles in width. It serves as the primary source of the river Ganges, one of the most culturally and economically significant rivers in the world. It originates near Chokamba Peak at an elevation of around 23,000 feet. This glacier flows northwest before turning southwest, descending through a valley of steep rock and moraine. The glacier terminates at a site known as the Gomukh, meaning the cow's mouth, named for its distinctive ice cave that kind of resembles a cow's head. This glacier is considered sacred in Hinduism, as the Ganges River is believed to originate from the goddess Ganja's descent to Earth. The pilgrims travel to the small nearby town of Gangotri each year to worship and witness the glacier that gives birth to this sacred river. Surveys and satellite imagery show that the glacier has been retreating steadily since at least the mid-20th century. Between 1935 and 2020, it receded more than 1.2 miles, exposing new rock and debris fields, and this retreat is primarily linked to regional warming, reduced snowfall, and soot deposition from industrial pollution. Seasonal melt from the glacier does also contribute substantially to the river's summer flow, especially before the monsoon. As the glacier thins out, this natural water reserve risks long-term decline, potentially affecting water security across South Asia. Despite its vulnerability though, Gangotri remains a powerful sight. It's a huge body of ancient ice hugging the Himalayan peaks. It embodies the spiritual essence of India's mountains and the scientific urgency of understanding a glacier on which an entire civilization depends. Number 6. The Petermann Glacier, Greenland. The Petermann Glacier, this is located in northwestern Greenland. It's one of the largest outlet glaciers in the northern hemisphere and among the most scientifically important ice streams on the planet. It stretches for about 50 miles from the interior of Greenland ice sheet towards the Arctic Ocean, and it terminates in a huge floating ice tongue that's up to 12 miles wide and more than 2,000 feet thick. This makes it one of the longest and one of the few remaining intact ice tongues in Greenland. That's a unique hybrid between a grounded glacier and an ice shelf. Early mapping expeditions in the 1870s confirmed its immense size, but it wasn't until the satellite era that scientists began to understand just how crucial it is to Greenland's ice dynamics. It drains roughly 4% of the entire Greenland ice sheet. That's an enormous volume of ice that, if fully melted, it would raise the global sea levels by several centimeters. In August 2010, a chunk of ice measuring 260 square kilometers, that's 100 square miles, about 4 times the size of Manhattan, broke off from the glacier, creating one of the largest icebergs ever recorded in the Arctic. Just 2 years later, in 2012, another massive calving event removed an additional 50 square miles of ice. These losses have shortened the glacier's ice tongue by about 25% in a decade, allowing more ocean water to flow beneath it. This undercutting effect weakens the glacier's structure, making it more vulnerable to future breakup. Research teams from NASA's Operation Icebridge and the European Space Agency have all conducted extensive aerial and satellite surveys to monitor its evolution, and they're mapping the subglacial topography and measuring the velocity of the ice flow. But perhaps the most intriguing discovery came in 2019, when scientists detected 2 giant meltwater channels beneath the glacier, each the size of a major river carved by warm ocean currents. These channels are slowly widening, creating these hidden caverns that could accelerate the glacier's retreat if they expand. Yet, in typical Arctic complexity, Petermann's surface flow has shown intermittent slowdowns during the colder winters, showing that local weather cycles and ocean patterns play major roles. But the glacier's fjord, Petermann Fjord, is one of Greenland's most visually amazing landscapes. It's framed by the rock cliffs and more than a kilometer of high and dotted drifting icebergs. Few humans have ever visited its front, but satellite imagery reveals the delicate balance of blue ice, shadow, and open water that defines this remote frozen world. Number 5. The Malaspina Glacier in Alaska. The Malaspina Glacier is along the southeastern coast of Alaska near the Yakutat Bay. It's one of the most visually remarkable glaciers. Unlike most glacier valleys that flow in a narrow channel, Malaspina is a Piedmont glacier. That means it's a massive fan-shaped sheet of ice that spreads out when descending from confined mountain valleys. It covers about 1,500 square miles, and it is the largest Piedmont glacier in the world, and a great example of ice sculpting on a continental scale. It originates from the St. Elias Mountains, and it's fed by several enormous valley glaciers, including the Seward and Agassiz glaciers. The tributaries converge in a basin just inland from the Gulf of Alaska, where the ice slows and spreads laterally into an expansive lobe of about 40 miles wide. From above, it kind of looks like a frozen delta with long, curving ridges of moraine debris that streaks across the surface, and that's evidence of thousands of years of movement. This is a cornerstone for understanding glacial mechanics, sediment transport, and long-term landscape evolution. The dark debris covering the surface is consisting of rock, sand, and volcanic ash, and that plays a huge role in regulating its melting rate. In places, this layer acts as insulation, protecting the ice sheet below from direct sunlight, while in thinner patches it absorbs heat and accelerates melting. Some sections of this glacier are over 2,000 feet thick, and radar studies have revealed that the ice beneath the central lobe continues flowing outwards, deforming under its own weight. Over thousands of years, it's built a natural ramp of glacial deposit so big that it's visible from space as a distinct semicircular feature along the Gulf of Alaska. But despite this relative isolation, Malaspina has been a focus of extensive research by NASA and the USGS. Recent radar mapping and satellite interferometry have shown that the glacier's lower regions are thinning rapidly. Warming air temperatures combined with increased rain and ocean proximity have created a complex meltwater network beneath the glacier. Now, these flows underneath it act like lubricants, which allows the ice to move more quickly towards the coast. Scientists are really interested in Malaspina because it's massive. The low-lying lobe may one day detach and collapse into the Gulf of Alaska, forming a floating ice platform similar to a small Antarctic ice shelf. Such an event, though not imminent, would dramatically reshape the local landscape, and it would provide some interesting insight into how coastal glaciers around the world may respond to warming climates. From the air, it's alien and majestic. It's like a frozen fan of light and shadow that stretches from the snow-covered mountains to the Pacific. Number 4. Pine Island Glacier, West Antarctica. So Pine Island Glacier is located in West Antarctica's Amundsen Sea Sector. It's one of the most critical glaciers on the planet and one of the fastest changing. It spans about 155 miles inland from the coast, and it drains an area of nearly 67,000 square miles. This river of ice is one of the primary outlets for the West Antarctic ice sheet, a region that alone holds enough ice to raise global sea levels by more than 10 feet if it fully melted. The glacier was first mapped during the aerial surveys in the 1940s, but it really wasn't until the first satellites that scientists realized how dramatic it truly was. Starting in the 1990s, radar imagery revealed that Pine Island was losing ice at an accelerated pace. Between 1990 and 2020, the glacier's ice flow speed nearly doubled, from about 2.5 kilometers a year to about 3 kilometers per year, while its floating ice tongue had thinned out by tens of meters annually. The cause of this lies beneath the ice. Warm water from the deep ocean, known as the circumpolar deep water, has been entering the subglacial cavity beneath Pine Island's floating ice. This warm current, just a few degrees above freezing, is enough to melt the glacier's base from below, eroding it where it meets the ocean. Its grounding line sits on a reverse slope, meaning the bedrock beneath it dips downwards towards the center of Antarctica. Now, this configuration does allow warm water to intrude deeper under the ice as the glacier retreats, which creates a feedback loop known as marine ice sheet instability. Once this process begins, it can be very difficult to stop it. In 2015, scientists recorded a massive calving event that detached an iceberg nearly 230 square miles in size. Subsequent events in 2017, 20, and 21 have further fractured the glacier's ice front. NASA data shows enormous rifts and cracks extending far inland, and that may indicate structural failure is progressing at a faster rate. Despite the grim outlook, though, it remains one of the most closely studied glaciers in the world. In 2020, autonomous underwater vehicles successfully mapped the underside of the glacier, revealing channels that were carved by warm seawater that extend more than 60 kilometers or 37 miles inland beneath the ice. For scientists, this glacier is a lab, and it's kind of a warning. It's showing in real time how ocean-driven melting can destabilize massive ice systems, once thought to be relatively stable. Every year, its retreat shows measurable increase to global sea level, and its future trajectory may determine how much coastal infrastructure, like cities, ports, and entire ecosystems, have to adapt within this century. Its collapse may unfold over centuries, but in human terms, it's already one of the most dramatic transformations happening on the Earth today. Number 3. The Denman Glacier, East Antarctica. Alright, we're going to stay in Antarctica here. On the opposite side of the continent, the Denman Glacier presents a different but equally alarming story. Located on Antarctica's Queen Mary Land, Denman is about 12 miles wide and stretches about 62 miles inland from the coast. Though smaller in area than the Pine Island, Denman descends through the deepest known canyon on the planet, one that goes down more than 11,500 feet below sea level. This makes Denman not just another glacier, but it's kind of like a geological anomaly. Its base lies deeper than the bottom of the Mariana Trench when measured from sea level. Beneath its ice flows a massive subglacial trough filled with a dense pressurized seawater and sediment. This configuration makes it one of the most potentially unstable glaciers on Earth. For decades, scientists assumed East Antarctica was relatively stable, but data collected by the ESA's Cryosat-2 and NASA's ICESat-2 tell a different story. Between 1979 and 2017, Denman's grounding line retreated about 3 miles, and its rate of ice loss has accelerated since the early 2000s. The topography beneath Denman is what worries scientists the most. Radar mapping has revealed a deep inland basin filled with marine-based ice, extending for more than 62 miles inland. If warm water continues to advance into this cavity, it could destabilize the ice farther inland and unleash a long-term collapse. That process could take centuries, but once it's initiated, it may be irreversible on human timescales. Still though, Denman is not yet in full retreat. The upper portions remain thick, cold, and heavily buttressed by surrounding ridges. These ridges currently act as natural barriers, temporarily holding the glacier in place. Continued monitoring by the Australian Antarctic Division and U.S. research institutions has shown subtle, year-to-year increases in ice velocity, which is an early sign that internal stress might be building. From a purely physical standpoint, though, Denman is amazing. Standing on top its surface would mean standing above the deepest continental canyon on the planet, hidden beneath kilometers of ice. The glacier is invisible to the naked eye, yet it exerts an influence on a global scale, thousands of kilometers away from any coastline. Like Pine Island in the west, Denman now represents a sleeping leviathan, a glacier that's perched at the threshold between stability and irreversible change. What happens here will echo across the world's oceans long after the current century has passed. Number 2. Thwaites Glacier, West Antarctica. The Thwaites Glacier, this is often referred to as the Doomsday Glacier. It's one of the most significant and closely monitored ice formations on Earth. It's located in West Antarctica, adjacent to the Pine Island Glacier. It stretches about 75 miles across and drains an area roughly the size of Florida, about 74,000 square miles. It flows from the heart of West Antarctic ice sheet into the Amundsen Sea. It's grounded on bedrock that lies as much as 3,900 feet below sea level, and that configuration makes it vulnerable to oceanic intrusion, as warm, dense circumpolar deep water can flow underneath the glacier's floating ice tongue. Since the 90s, the grounding line of Thwaites has retreated more than 9 miles inland, and its ice velocity has nearly doubled. Satellite radar interferometry reveals that the surface has lowered by several meters per year in places, which indicate rapid thinning. Current estimates suggest that Thwaites already contributes about 4% of annual global sea level rise, which is an astonishing figure for a single glacier. But the real concern is that Thwaites holds back the entire West Antarctic ice sheet behind it. If its collapse destabilized adjacent glaciers, global sea levels could rise by over 10 feet. Because of this potential global impact, Thwaites is the focus of the International Thwaites Glacier Collaboration, a joint effort between the United States and the United Kingdom involving hundreds of scientists. This is one of the most comprehensive Antarctic research missions of the 21st century. Studies have shown that portions of the glacier's bed lie on a reverse slope, dipping down towards the interior. This means that once warm water breaches the grounding line, it can progressively melt its way deeper inland, triggering a self-reinforcing collapse. That's a process we talked about as marine ice sheet instability. Despite that grim nickname, though, Thwaites' fate is not yet sealed. Some models suggest that short-term stabilization could happen if ocean currents cool temporarily or if sea ice formation increases around the Amundsen Sea. However, most long-term projections show that continued retreat over the next century. The glacier is currently losing about 50 billion tons of ice per year. That's equivalent to the combined annual water usage of major countries. Seen from above, it looks deceptively static. It's a bright white expanse that merges with the neighboring ice flows, yet beneath that surface is a slow-motion crisis. Its movement is so immense that satellites detect it shifting by meters in a single day. If Pine Island was the warning, Thwaites is the tipping point, a system whose balance could determine the shape of global coastlines for centuries. Number 1. The East Antarctic Ice Sheet. The East Antarctic Ice Sheet is, by far, the largest accumulation of ice on the planet. It is a colossal frozen world that defines the eastern half of the Antarctic continent. It covers roughly 3.9 million square miles, an area nearly the size of the entire United States, and contains about 6.5 million cubic miles of ice. By any measure, it is the single most massive and important ice structure on the planet. This ice sheet extends from the Transantarctic Mountains, which divide the continent, all the way to the coastline facing the Indian and Pacific Oceans. In many places, the ice is over 13,000 feet thick. That's so thick it's depressed the land beneath it thousands of meters below sea level through sheer weight. Its surface is an endless plateau of wind-sculpted snow, shaped by katabatic winds that race downslope from the interior towards the coast at speeds exceeding 60 miles an hour. At its heart, near Dome A and Dome C, temperatures routinely drop below -110 Fahrenheit, and snowfall is so scant that these regions are technically deserts despite holding most of the world's fresh water. For much of the 20th century, scientists considered the East Antarctic ice sheet as stable and largely immune to climate change. Its big size, extreme cold, and the isolation seemed to protect it from the melting seen elsewhere. However, satellite observations over the last 2 decades have revealed a more nuanced picture. While the central plateau remains frigid and stable, portions of the coastal margins, especially near the Totten, Denman, and Cook glaciers, are beginning to show signs of change. The Totten Glacier in particular has drawn global attention. Studies have confirmed that the circumpolar deep water, that's the warm ocean current, is melting its underside at an accelerated rate. Similarly, the Denman Glacier, which descends through the deepest land canyon, is losing ice along its eastern flank. These localized changes suggest that parts of the ice shelf may be more vulnerable than previously believed. Still, though, the interior remains extraordinarily stable. Radar and ice core studies show that much of the central ice has been frozen in place for millions of years, preserving a detailed record of the climate history of the planet. Ice cores extracted from sites at Dome C and Vostok have revealed atmospheric data going back over 800,000 years, chronicling cycles of ice ages and warm periods. These records are the backbone of modern climate science, and they show clear links between carbon dioxide levels and global temperature shift. But from orbit, the East Antarctic sheet looks deceptively featureless, like a white continent stretching to the horizon. What makes it so vital is the dual nature of it. On one hand, it's stable, a relic of the Pleistocene that's endured for millions of years. On the other, it's a potential giant in waiting. Should global warming persist and warm ocean water reach the hidden basins in greater volume, even a modest destabilization could have planetary consequences. Today, scientists view it as both a fortress and a frontier, a huge, frozen safeguard that still holds steady, but ones whose edges are beginning to whisper a change. But in its silence is the story of Earth's past, and maybe the key to its future.